Here in session 95, solving higher degree equations is what we're going to be taking a look at. As a review, we listed this a little bit earlier on, but we have several different types of polynomial equations. We have what's called a linear equation, and that would be in the standard form of ax plus b equals 0. And even though we don't write it, this is x to the first. Our quadratic equation is in the form of ax squared plus bx plus c equals 0. So we can see that the degree of a linear formula, or a linear equation, is 1. It's x to the first. The degree of a quadratic equation is 2, because our biggest x value there, variable, is squared. Next we have what are called cubic equations. Ax to the third plus bx squared plus cx plus d equals 0. So in a cubic equation, we have the degree of 3. For a quartic equation, our highest degree in there is 4, and in a quintic, it is 5. We've already stated in previous lessons that a linear equation has just one solution, and that corresponds to the degree of the equation, the degree being 1. Remember, x is the same thing as x to the first. So in a linear equation, we have just one solution. In a quadratic equation, we can have up to 2 solutions. But remember, it's also possible that a quadratic may have just one solution, and it's also possible it may not have any. But the most it can have is 2. And that pattern does follow. In our cubic equations, the most solutions that we can have for any individual cubic equation would be 3, because that's the degree of the equation itself. In our fourth degree equation here, our quartic, the most solutions that we can have would be 4, and in our last one, our quintic, we can have up to 5 solutions. And remember, the number of solutions that we can have corresponds to the degree of the equation itself. Over here we have a higher degree equation. We have x to the third plus 7x squared plus 11x. Well, at this point we don't have any methodology yet to deal with trying to solve a higher degree equation, an equation greater than a quadratic. But if you take a look here, you can see that each of these 3 monomials here does have a common factor that is a variable. Each of these has a common factor of x. So what we could do to start off with is factor out that x. So let's go ahead and do that. Let's take the x and factor it out. X times what is x cubed? Well, that would be x squared. X times what is 7x squared? Well, that would be 7x. And then x times 11 would give us our 11x. So at this point, we know, and I should have written that that does equal 0. In the factored form now, we have x times x squared plus 7x plus 11 equals 0. Well, what we have here is a quadratic equation within the parentheses here. But before we even try to use the quadratic formula for this quadratic equation, what do we know right off the bat is a value for x that will make this equation equal to 0? Well, we know that if x is 0, that'll work, because remember, anything times 0 is 0. So it doesn't matter what value is on the inside of this parentheses here. If x is 0, it's going to multiply by 0 and make 0. So we do in fact know that one of the solutions to this problem is x equal to 0. But what I'd like to do is go ahead and move forward and try to solve the remaining portion here, the x squared plus 7x plus 11, using our quadratic formula. So we have x equals minus b, and what's our b value here? Our b value is 7, so minus b would be minus 7, plus or minus the square root of b squared. Well, b is minus 7, so we're going to have that squared, minus 4 times a is 1, times c is 11. all over 2a. And what's our a? Our a is a 1. So it's just over 2. Now let's go ahead and simplify. We have minus 7 plus or minus the square root of minus 7 squared is 49. Minus 4 times 1, minus 4 times 1 is minus 4, and minus 4 times 11 is minus 44 over 2. Taking it just one step further now, that's going to give us x equals minus 7 plus or minus the square root of 5, because 49 minus 44 is 5, over 2. This right here now tells us our different solutions. We know that a solution works for x equals to 0, and then for this quadratic equation, x equals minus 7 plus radical 5 over 2, and then x equals minus 7 minus radical 5 over 2. So in this situation, those are the three solutions to this cubic equation. Okay, let's take a look at one more here. This one will be a little bit simpler. We have x to the 5th minus 2x to the 4th minus 3x to the 3rd. And we want to find the values or the solutions for x that will work to make that equal to 0. Well, at this stage here, we don't have any methods of dealing with degreed solutions or degreed equations that are greater than 2 or greater than a quadratic. The only thing we can hope for is to find a common factor of a variable that we can then bring out that will then reduce what's left to a quadratic formula or lower, or a linear. Well, if you look at x to the 5th and minus 2x to the 4th and minus 3x to the 3rd, we can see that x to the 3rd is a common factor. So let's go ahead and factor out x to the 3rd. X to the 3rd times x squared is x to the 5th. That takes care of that first monomial there. X to the 3rd times minus 2x equals minus 2x to the 4th. That takes care of that. X to the 3rd times minus 3 equals minus 3x to the 3rd. And we know that that equals 0. Well, once again here, before we start factoring even further within the parentheses, if we can get x to the 3rd equal to 0, we know that whatever that value will be one of the solutions. Well, x to what to the 3rd power equals 0? Well, 0 to the 3rd power equals 0. So we know that one of the values that will work here is when x is equal to 0. But what we're wanting to address now is this x squared minus 2x minus 3. We could go ahead and use the quadratic formula to determine the values of x that will work here, but we could also solve it by factoring. Let's take a look at the x squared minus 2x minus 3. That's a pretty straightforward and simple factor. I'm going to rewrite the x to the 3rd, and then we're going to break apart x squared minus 2x minus 3. We're going to have an x here and an x here. That takes care of our x squared. Then we need factors of 3. Well, we can only do 1 and 3. Those are the only two factors of 3 because it's prime. But we're after a minus 2x. That tells us that our 3 is negative and our 1 is positive. And remember, that needs to all equal 0. So the first thing we found out is that when this value out here, x to the 3rd, when 0 is put in here, 0 to the 3rd is 0, and then everything else that's left here when multiplied by that 0 will give us a 0. So x equals 0 is the first solution. The second solution would be when this second term is equal to 0. Well, x plus 1 equals to 0. What does the x have to equal? Well, the x would have to equal minus 1. Because minus 1 plus 1 is 0. That gives us 0, and 0 times anything else will give us 0. That takes care of the first two. We found out for the x to the 3rd, that works when x is 0. For the x plus 1, that works when x is minus 1. What about our last term here, x minus 3, our last polynomial? That works when x is 3, because when x is 3, 3 minus 3 is 0. And then 0 times whatever else is left will give us an answer of 0. So for this last problem here, x to the 5th minus 2x to the 4th minus 3x to the 3rd, we first of all factored out our x cubed. That left us with x squared minus 2x minus 3. We then took that and factored it into x plus 1 and x minus 3, and then we found out the solutions here for x that would then make each of the terms or polynomials that x was a part of 0, which means that when multiplied by that would give us 0. So for this particular equation here, we have 3 solutions. Now remember, even though it's an x to the 5th, it doesn't tell us we have 5 solutions. It just tells us we can have up to 5 solutions, but you can have less. And as we saw here, for this particular equation, there are in fact just 3 solutions. Over to our review, a polynomial equation to the nth degree can have up to n solutions. So if n were 9, if we had a polynomial equation to the 9th degree, that equation can have up to 9 solutions. If we have a polynomial equation that's a quadratic, which would be to the 2nd degree, we can have up to 2 solutions, and so on. To solve equations to the 3rd degree or higher, first of all, try factoring out of each monomial a common variable factor so that it leaves you with a quadratic equation, or even, in fact, a linear equation. If you're left with a quadratic equation, then use the quadratic formula or any other quadratic equation strategies to solve that remaining equation. That'll wrap up then session 95.